Okay, let's take a look at what are decision trees. We want to take a look at what are the key differences between decision trees and regression. And after that, we can take a look at what are the tree building and pruning process. And then want to differentiate between classification trees versus regression trees, with some examples to show you the application of trees. So first of all, I'm going to start with regression trees. So let's take a look at regression itself. Regression models are well tested, extensively studied, robust, and work even with moderate violations of the assumptions. So we studied regression previously, and we know it can be applied in many different scenarios. However, with large number of variables, regression becomes difficult to use. And it has two cases happened. One is relationships are nonlinear. And the second thing is variables interact. So just be aware when you have more variables, uh, a, a large number of variables in your data set, and then you want to build a nonlinear regression, and then there are cases that variables interact, then it's not that great to use regression model. That's why in that case, we start thinking about decision trees. So let's look at decision trees. Trees are particularly useful when using large number of independent variables, and when there are likely to be nonlinear relationships and interactions amongst variables, and when interpretability of results is important, because decision trees are easy to be interpreted. At the same time, trees often perform poorly in predicting relative to the best supervised learning approaches, meaning decision trees are not doing so well comparing to some other supervised learning methodologies, which we would be studying down the road as well. It tends to overfit the data. So you have to somehow to deal with the overfitting issues in decision trees. Good news is the overfitting can be remedied by cross-validation. So you have to go through the cross-validation processes. So this is the overview of the difference between regression and decision trees. So when you need to pick the proper methodology, you want to think through some of these aspects. Meanwhile, should also pay attention to potential pitfalls if you use one methodology versus the other. So what are decision trees? These involve stratifying or segmenting the predictor space into a number of simple regions. So predictor space essentially are the variables, or we call it independent variables. And then we're trying to segmenting the independent variables into different spaces. And I'll have an example for you very shortly so that you know what I'm talking about here. Since the set of splitting rules used to segment the predictor space can be summarized in a tree, these types of approaches are known as decision tree models. So it's exactly look like a tree, except that it's inverted, meaning that its root is in the top. These are also referred to as CART, classification and regression tree, after the family of models used for tree algorithms. They can be used for metric prediction problems or non-metric classification problem outcomes. So if your outcome are numeric, then it's a regression problem. So we call it decision tree regression. And then if your output are non-numeric, it essentially is categorical, then it's a decision tree classification problem. Okay, that's the difference between those two. Let's look at this data. So you have some scatter plot of simulated data. You can see apparently it lives in 3 major regions, right? This x-axis 0 to 5, and y-axis 0 to 5, and then x-axis 5 to 10, and y-axis 15 to 20. And the third region is x-axis 15 to 20, and y-axis is around 5 to 10. So that's 3 areas. Let's think about if we run this data through a linear regression, what output potentially we can get. See, this is a possibility, right? You run this in linear regression model, and then turns out to be this. And then apparently you would be aware that it's not doing that great, right? The question becomes, are we able to fit a different model to do the prediction? So let's think about a tree model plot. So if we are able to design an algorithm that can model the problem that we just saw, the data we just saw, then we could say, okay, if x is less than 5, if it's yes, we can give a value, and then if it's not, it would be larger than 5. And among the data that's larger than 5, you can potentially even split into 2 pieces. One of them is less than 10, the other one is larger than 10. And then you use some sort of value to predict this region versus the first region separately. That's really the idea. So you have less than 5, give a value, and then if it's larger than 5, then try to continue to split. And among the larger than 5 regions, you could split to 2 pieces. One region is larger than 10, the other one is less than 10, so that you can use different values to predict the 3 regions. So we'll go to the detail shortly as well, but here is really the idea for decision tree. Now here is the fitting process. The first step, larger than equal, whether it's larger than or less than equal to 5, as I just mentioned. And the second step, whether it's larger than or equal to 10 or less, just for the second node. Now this would be our tree, and then we use the average of all the data that's belong to this region to be my prediction. And then the same thing for here, same thing for the third region as well. Now let's put those two together. You can clearly see that the decision tree regression model is doing a better job than the regression model itself, linear regression itself, right? Okay, so some terminology you should be aware. Trees are drawn as inverted tree. In other words, the root is really in the top. And the first split point is called the root node. Root is in the top, and then we come up with a decision that is some sort of threshold and some particular variable. In this case, we only have an x. That's why we use x. And then the nodes below the root node are interior nodes and are linked to the root node by branches. So the first branch that we just saw was x larger than 5 on the left-hand side. And then the second branch we saw is like x less than 5 on the right hand side. X larger than 5 on the left-hand side, and x less than equal to 5 on the right-hand side. And then on the end nodes I called leaves. Okay, so if we go back here, take a look at this. So what we're saying is This is called root node, and those two different branch. And then each of these end nodes, colored by green, are called the leaves. So one more time, if you go back here, try to understand all of the terminologies. We're going to use all of this throughout the rest of the sessions. So this is the introduction to the decision tree, and then we'll continue from here. Thank you.